Okay, here we go. So, like I said, a radian is a measure of the central angle that intercepts an arc and is the length of the radius. So we just kind of showed that in that little GIF of the radius curving to look like a radian. Okay, so I'm going to draw that. If this is my radius, okay, theta is another variable that looks like x. It's just a Greek symbol, and it usually represents our angle. Okay, and then our arc here is going to be the same length of our radius as well, but in radians. Okay, who remembers how we find circumference?
2 pi r.
Very good. C equals 2 pi r. What's the other way you can find it?
dr. Pi d.
Very good. Pi times diameter.
What's d? Diameter.
Yes. So, like I talked earlier about the fact that our unit circle will be heavily used in pre-cal, and on your unit circle, your radius is 1. So, if the radius is 1, okay, then what would be the length in radians of your whole circle? So, what would be the circumference if your radius was 1? 2 pi. And that's what we talked about in that video as well. Okay, so our starting point represents 0 degrees. Okay, how many degrees am I up here? 25. At the top of this arrow. 90. Keep going. I have 180. Keep going. 270. Okay, and then what else is over here? 360 degrees. Okay, so if I know that over here is pi, because the semicircle is pi, my starting point or my full revolution is 2 pi. Now I'm going to put my terms in radians around my circle as well. So if this is 0 and this is pi, what would 90 degrees represent? Pi over 2 radians. Okay, what would 270 degrees represent?
2 radians of pi.
1.5, which how would you write that? 1.5?
2 pi over 2. Oh, 3 over 2.
Guys, how do you write 1.5 as a fraction?
1 over 2. 2 over 2.
3 over 2. So you would have 3 pi over 2. Wow, that was rough. Okay. Now let's say that hold on, need a pen. Let's say that I split this directly in the middle, so this is 45 degrees. What would that be in terms of radians? What's halfway between 0 and pi over 2? Pi over 4. If you can't see, move up.
Can you, make it a little bit more?
No. Okay, what would be halfway between 90 and 180? Three pi over 4, and then what would the degree measure be?
135.
135 degrees. Okay, what would be between 180 and 270?
225.
225 degrees, and what would it be in radians?
4.
What's in between pi and 3 pi over 2? Very good. 5 pi over 4. Okay, and our last one, in degrees, what would it be?
320.
Not 320.
315.
315. And what would it be in radians?
7 pi over 4.
Very good. Okay. So, in degrees, every single line added how many? 45 degrees. So 0, 45, 90, 135, etc. Okay. In terms of radians, how much did you add each time?
2 quarters.
Mason, is that you that keeps saying 2?
Yeah.
Do you need to come sit by me? Okay, how much did you add? A quarter, pi over 4. Okay, because this is 0. Pi over 4. Pi over 2 is the same thing as 2 pi over 4. So it went from 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So you're adding 45 degrees and a fourth each time. Okay, so this is the type of stuff that you have to memorize in calculus. Okay, and you'll pick up on it super easy. However, we also have formulas to convert from degrees to radians in the event that you don't have it memorized. Okay, so again, a full revolution, 360 degrees is 2 pi, and 180 degrees is pi. Okay, that's still extremely important. You need to know that. Okay, now converting between degrees and radians. If you start in degrees, okay, you multiply the degree times pi over 180. Okay, if you start in radians, you multiply the radian measure by 180 over pi. Okay, so our examples, convert the following angles from degree to radian measure in terms of pi. If we're going degrees to radians, what are we using? What's the formula? Degrees to radians. Thank you. Degrees times pi over 180. So I have 45 times pi over 180. So I have numerator times numerator, denominator times denominator. So I have 45 pi over 180. Okay? You cannot just leave your answer like that. It has to be simplified. Okay? So if you don't know how to simplify it, or it doesn't look visually like it can be simplified, type it in your calculator and make sure, okay, that you have it in simplest form. So when you type it in your calculator, don't worry about the pi. Okay, pi is going to stay in your answer. We just want to see if 45 over 180 is going to reduce. So type in 45 divided by 180. Press math fraction, and it will put it in the simplest fraction for you. Okay, so what is the simplified fraction? 1/4. So it would be pi over 4. Okay. A lot of people are going to simplify it and then forget to put pi back in their answer, and they're just going to tell me 1/4. Make sure pi is in your answer, okay, when you're going from degrees to radians. And if you go back up to the top here, let's look. 45 degrees, pi over 4. Okay, so again, if you can't fill this out by yourself, there's a formula that can get you there. So again, 45 degrees was pi over 4 in our picture, and here we are again doing it algebraically with a formula. Yes, Mason?
If it was like 3/5, it would be 3 pi over 5.
Yeah. Okay, next one, 135 times pi over 180. So we have 135 pi over 180. Does that simplify?
Yeah.
To what?
3 pi over 4.
So it would be 3 pi over 4. Pi always either goes in your numerator or it goes off to the side. Okay, it is not ever in the denominator. Preferably, it should go in your numerator. That is how you're going to see it on tests and quizzes and everything else. Okay, do C and D real quick. Zara, did you message them?
Yeah.
Okay. Okay, what'd you guys get for C? 225 pi over 180 simplifies to what?
5 pi over 4.
Very good. 315 pi over 180?
7 pi over 4.
Awesome. Okay, and you could have used the table up here to do that. 135, 3 pi over 4. 225, 5 pi over 4. 315, 7 pi over 4. Okay, number 2, it says convert the angles from radian to degree. However, these ones we did not put on our unit circle up there. We could have easily added them and made smaller and smaller increments. I just stuck with those 8 originally. But to convert them from radians to degree, what formula are we using?
Radian times 180 divided by pi.
Radian times 180 divided by pi. Okay, so we have pi over 6 times 180 over pi. What do you notice happens?
The pi's cancel out.
Your pi's cancel out because you have 1 in the numerator and 1 in the denominator. Remember, anytime you have a 1 for 1 that's a cross multiplication, you can cancel them. Okay, so you have 180 over 6, which is 30 degrees. Make sure you have your units. You should have a degree symbol. It's not 30. 30 degrees. Okay, so now I have 5 pi over 3 times 180 over pi. Again, my pi's cancel. And I'm left with just 5 times 180 over 3. Or 5 times 180 divided by 3. And what do you get? 300 degrees. Questions on converting from degrees to radians and radians to degrees? Nada? Okay. Alright, the high school athletic department needs to build the fence along the outfield of the softball field. The outfield is an arc of a circle. What is the circumference of this circle?
385.
Okay, so we want it as if this was an entire circle. So what would it be? 385. Because you have C equals 2 pi r. So 2 times my radius, which is 190, is 380 pi. And then we want to make sure we have units. So feet. Okay, what is the degree measure of the central angle? What's the degree measure of that central angle? Anybody? 90 degrees. So what, the field is what fraction of this circle? 1/4. And the way that we find that truly is the degree that your central angle is over 360 degrees. So 90 degrees is what our central angle is over 360, which equals 1/4. That's how we get that 1/4. Because it's 90 over 360. So this numerator represents the central angle. Okay? What is the length of the outfield fence? So how do I figure out this? You're thinking arc measure. How do we figure out the length of this part of our fence? So what did I tell you that arc length represented at the beginning? What did I tell you arc length was? How did it differ from arc measure? Words, not even numbers, just words. How did the arc length and the arc measure differ? Yikes. I just told you guys this 12 minutes ago. Arc length is part of the blank.
Part of the radius. Circumference.
Part of the circumference. Your arc length pertains to part of the circumference. Your arc measure pertains to the degree of the arc. It's the same as the central angle, remember? Okay, so again, I told you guys, you have to pay attention today because you have to know how to differentiate between the two. So, if arc length represents part of the circumference, how am I going to figure out the arc length?
Oh, it's 90 because it's like the
No,
central angle.
no, it's not.
Because the central angle opens up and it's the same thing, right?
No, I said that. That's what she said.
So what do you think, Peyton?
It's 95, right?
But get that.
Because you take the circumference and you divide it by 4 because that's...
Oh, that's so simple.
Thank you. You take your total divided by or multiplied by the fraction. So that is how you get 95 pi feet because this represents 1/4 of the whole. Okay, so now we need to come up. Now we need to come up with the formula. Okay, this you can just scribble out. Let's write it over here. I think it got like tabbed over. You know how Word behaves terribly. Okay, so how would we figure out the arc length? What did we just do? Okay, so if your central angle is in degrees, okay, we took 2 pi r, which is our circumference, and what did we multiply it by? So right here, we took 2 pi r, which is 380 pi. We multiplied it by 1/4 to get 380 pi over 4. What was that 1/4? What did 1/4 represent? The fraction of your circle. Okay, and we did that by finding theta, which is our central angle, over 360. Remember right here? So theta over 360 times 2 pi r, or 2 pi r times theta over 360. Okay, again, that's only if your central angle is in degrees. Okay, if your central angle is in radians, your arc length is found by taking that central angle, whatever it is, theta, whatever radians, okay, and you just multiply it by the radius. Okay, so who remembers what 90 degrees is in terms of radians?
2 pi over 2.
Pi over 2. Okay? Because remember, right here, pi over 2 at the top, 90 degrees. Okay, if you didn't know that, you could convert from degrees to radians like we did on the front and get pi over 2. Okay, so if that's pi over 2, okay, if you take 190 feet times pi over 2, which is our central angle, what do you get? Which is? What did you say? 95 pi. So do you see how we arrived at the same answer, but one was using the degree formula, and one was using the formula if you have it in radians. Okay? So, two different things. Okay? The important thing here is that theta does not necessarily mean it is in degrees. It just is the Greek symbol to represent an angle. Okay? All that is a Greek symbol that represents an angle. And an angle can be measured in degrees or radians. Yes. Okay. So again, a degree can be measured in an angle can be measured in degrees or radians. Okay? Questions on that? Okay. We're going to practice. So C is the center of each circle. Find the length of each darkened arc and leave your answer in terms of pi. Okay, that's key here. Leave it in terms of pi. Don't multiply it out. Okay, what is the measure of theta in number 1?
90 degrees.
90 degrees. Okay, 90 degrees is equivalent to what in radians?
Pi over 2.
Pi over 2. So you could use this with the degree formula or the radian to make sure that you substitute in the right value. Okay, so which one do you guys want to use?
Degree.
Okay, we can do them both ways if you want. So if you have 2 pi r, you have 2 pi times 8, which is our radius, times theta over 360, which is 90 over 360, simplifies to 1/4. Okay, so I have 16 pi times 1/4, and so what am I going to get as my arc length? 4 pi what? Centimeters. Make sure you have your unit. Okay, similarly, okay, if I were to have done the radian formula, I would be using pi over 2 times my radius, which is 8, and that would be 4 pi. So again, it doesn't matter which formula you use, but make sure that you substitute the right thing, because if I accidentally substituted 90 times the radius, that would not end out very well. Okay, try letter B on your own. Pay attention to which arc you are solving for. Make sure you use the appropriate angle. What would be the angle that you're using for B? 240 degrees. Okay, because you know that all of it has to be 360. So 360 minus 120 and you'll get 240. When your numbers are large, like 240 and 360, it might be easier to simplify this fraction first, and then multiply. Your numbers will be smaller. What did you guys get?
32 pi over 3.
32 pi over 3. Very good. Centimeters. Don't forget your units. You'll start losing a lot of points because it's 1 every single time. What about it? What don't you get? That's not an answer. Okay. Is your central angle in degrees or is it in radians? Degrees. So what formula are you using?
2 pi r times, I don't know, circular divided by 360.
Okay, and what is that circular thing in this picture? Right, and what is that in letter B?
240.
240, so substitute in.
That's it?
That's it.
And then solve the third one.
Questions on A or B? Nothing? Okay. Number 2. If the circumference of a circle is 400 pi, find the diameter, radius, and length of an arc of 240 degrees. Okay? If the circumference is 400 pi, how am I going to figure out the radius from that?
You
Pi.
you take 400 pi and you equal it to 2 pi r.
Very good. 2 pi r
And then solve the equation from there.
equals 400 pi, because that's our formula that we use to find circumference. Okay, so if I divide both sides by 2 pi, your pi's do what? Cancel, because there's 1 in the numerator and 1 in the denominator. So your radius is left as 200. Makes your diameter what? 400. And because they don't give us units, we can just put U. Okay, so how do we find arc length? You know the measure of your arc is 240 degrees, so how do you find arc length? You don't have to.
It's 2 pi times 200 times, what's the arc? Times 240 over 360.
So 2 pi times 200 times 240 over 360. 240 over 360 simplifies to what? 2/3. So you have 2 pi times 200 times 2/3, and what does that equal?
Yeah, so
800 pi over. That's your favorite thing to say.
What?
Ask questions rather than just say, I don't get it. I can't help you if you just say, I don't get it. I found the arc length. Again, the angle is in degrees, so you take theta over 360 times 2 pi r. Okay. Example 3. Find the length of EF below. Okay, and I think it meant arc EF because that's what's down here. Okay, so I'm going to highlight that arc. Is that a major or a minor arc? Minor. How do you know it doesn't go this way?
Because it's only 240.
because there's only 2 points. You need 3 in order to classify a major arc. Okay? So, it wants us to find that arc length. Mason, you're going to lead the way. What is your central angle, in degrees or radians? Degrees. So, what is our formula for finding arc length if our central angle is in degrees?
2 pi r equals angle.
Not equals, but 2 pi r times
Angle
over.
360.
Very good. And what is my angles?
120.
120. What is my radius?
6.
Okay, so I have 2 pi times 6 times 120 over 360. Mason, what does 120 over 360 simplify to?
2/3. 1/3.
1/3. Okay, so I have 2 pi times 6 times 1, which is 12 pi over 3. And 12 pi over 3 simplifies to 4 pi.
I understood that.
They were all the same as that.
There's more steps.
Okay, find the length of LM. What is the central angle measure that... How do you know that?
Because
About
here,
300 minus 360 is 60.
Okay, so if you know that this is 60, how did you know that this central angle is 60?
Because the central angle is equal to r.
Very good. The central angle is the same measure as its minor arc. Okay, so Mason,
Yeah.
is my central angle in degrees or radians?
Degrees.
Degrees. So what formula do I use?
2 pi 3 equals 60 divided by 360.
Very good. Times,
4.
not equals. Okay, 60 over 360 simplifies to what?
I have no idea. Equals
1 over 6.
1 over 6. 6 pi times 1 over 6. So it's 6 pi divided by 6, so it's 6 pi.
Very good. Are you catching on?
Yeah. Do you want me to ask you to do this one? Oh wait, I know how to do it. They don't.
Okay, example 5. What is my central angle?
2 pi divided by 3.
2 pi over 3. So am I using, or is it a radian or is it a degree?
Degrees.
It's a radian, and when you have a radian as your central angle, what formula do you use?
181. No, it's beta times r.
Okay, so you have 2 pi over 3 times what?
6.
6.
6 over 1 actually. So it's 12 pi divided by 3, so it equals 4 pi.
Good job.
Thank you. Yeah, that's awesome.
Okay, last one, do on your own.
Oh, Frank.
Oh, wait, I won't do that to you.
Wait, please don't.
Okay. It's not necessarily hard, but
Wait, how do you do that?
can you give me 1 second?
Yeah, say that.
What is the entire circle,
360.
or in radians that is,
Oh, 2 pi.
2 pi. So, if this part's 5 pi r, you have 2 pi minus 5 pi r, or sorry, 5 pi over 4. Just like you would do 360 minus 240, or whatever it is. So what are you left with?
3 pi over 4.
Nice. So 3 pi over 4 is over here. Our central angle then is what? 3 pi over 4. Remember, your angles can be in radians or degrees. Okay, and so now how do I find the length of LM?
Okay, so it's that 3 times the radius. So it's
9 pi over 4.
3 pi divided by 4 times
9 pi over 4.
over 1. So it's
Okay,
9
Nathan.
pi divided by 4.
Okay.
9 pi.
Let him talk it out.
Real quick, I'm going to give you some other practice that might help you in your future. Okay, first things first. Speed round.
Wait, what?
Conversions. I'm going to give you 3, and you're going to see how fast you can do them.
Oh.
Okay? You're either converting radius to degree or radians to degree or degrees to radians. Got it? I'm going to give you 3. No cheaters.
Right.
I really want to win.
I'm gonna be last.
Ready? Go!
Wait, hold on. I'm not gonna be first, but I'm gonna cry.
Accuracy is more important than speed.
Wait, isn't it? Okay.
Because you're converting it from radians to this is your radians, that's number 1, if you do this,
Done.
multiply by this.
Did I win?
You're first so far.
I'm about to do it, hold on. Wait, I wait.
Is the last one 2 pi divided by 3?
Yes.
Alright, cool, guys.
No. What did you get?
10.
Is the second one? I got it.
I got it.
What'd you get?
Wait, what did you get?
3. Alright, what did you guys get for number 1? Number 1.
45.
45 degrees. 2.
3 pi over 10.
And 3.
120.
That one.
Okay, I've got more for you. Just wait.
Wait, where are we writing this?
You will write it in a second. Okay, ready?
Yeah.
The first one has a radius of 4 inches and a degree of 45 degrees, and the second one has a radius of 6 inches and a degree of and a radians 2 pi over 3.
So much better. 4 inches, 6 inches. Alright, okay. We're going to, oh yeah, 2 pi r equals the angle divided by 360.
If it's in degrees.
It is.
Hold on.
Yeah. No, times, not equals.
Miles, you should be doing this. Do this. You're finished?
2 pi over 3 times 3 is 6.
Our
No, but it's asking for radius of the first one.
Yeah.
Oh.
2 pi divided by 3. Is that right? 2 pi divided by 3 is the angle. 2 pi divided by 3.
And 3 pi over 3, 4 pi.
Yeah.
Yeah, show me.
I told you.
Yeah.
1 minute.
I got 5. Hold on. I got 5.
It is right. And 4 pi.
Hmm?
Pi is 4 pi.
Did you convert it?
Over to what?
To radians into degrees?
How do you do that? Oh wait, is it this thing?
Ours like is pi.
Okay, what is the radian measure for the first one?
Pi.
No, that's the arc length.
I mean, so it's pi times 185.
What is the radian measure for the green one? 45 degrees is equal to what? Pi over 4. So what is the arc length? Pi. Oh, I have inches. Okay, what is the degree measure? 2 pi over 3 is equal to what? 120. And the arc length is 4 pi. Okay, this is the style that your skills check is going to look like. Conversions and arc length, conversions and arc length, conversions and arc length. Okay, keep in mind that once you find the conversion, you have both now the radian and the degree measure. So you can use either one of your arc length formulas. Okay, you don't have to just use the one that the picture provided. After you have 120 degrees, you could have used the degree one, not just the radian one. Questions on the notes? Okay, you have 20 minutes until the skills check. You are responsible for memorizing those formulas and knowing how to apply them appropriately.